Artificial intelligence is maybe the biggest buzzword of all time. We're going to talk about today what it really means and all the different facets and directions that it can go in. Welcome to Kopek Explains Software, the podcast where we make computing intelligible.
Okay, Dave, today we're going into what some may think is a sci-fi movie, but is actually really impacting so much of software these days, and a topic that folks have a lot of curiosity and a lot of misinformation about, I think. What is artificial intelligence?
Artificial intelligence is a really broad topic. There's a lot of sub-disciplines of it, and we won't be able to go into every sub-discipline today. So we're going to give people a broad overview and maybe go into just a few of the sub-disciplines that people are particularly interested in. But artificial intelligence is about trying to make computers do actions that we think about as intelligent. Obviously, the computers are the artificial part. The intelligent part is that these are actions that are similar to what other intelligent beings might do. Not that computers are beings, but humans, right? Humans, we think about ourselves as intelligent, and we're doing all kinds of interesting things every day. Is it possible to artificially make a computer do some of those intelligent things that we do? That's what artificial intelligence is about. Now, that doesn't mean that we actually are always able to make the computer behave in the same way as a human being. It just means that it's able to complete some of the same tasks that a human being is able to complete.
So one of the things when we were preparing for this episode that you said is that there's actually opinion into what is our artificial intelligence. There isn't a agreed upon by the whole software world or computer science world of what is artificial intelligence. Can you talk a little bit about that?
Yeah, it's interesting. My dad actually had a PhD in machine intelligence, which is another term for artificial intelligence. And he wrote a textbook on artificial intelligence. And he himself said, there's a lot of people who disagree on what the formal definition is of artificial intelligence. So what we're going to have to use for today is just my own definition, because that's the only way we can have a conversation and have some point of truth to spring off from. So my definition is basically what I said earlier, which is it's having computers do the same kind of intelligent actions that human beings do. However, there are two different main categories of artificial intelligence. There's strong artificial intelligence and there's weak artificial intelligence. And I think this is where a lot of the confusion comes about the definition and about where different people are coming from when they use the term. So strong artificial intelligence, that would be a general purpose learning machine that's equivalent to human beings and abilities. That's the goal of strong AI. That's also known as artificial general intelligence. At this point in history, we don't have anything like that, and I'll go into that again in a couple minutes. But then there's also weak AI. So weak AI is the everyday type of AI that you see all the time, like a computer being able to classify a picture by what's in it, or a computer being able to play chess. That doesn't mean it has the full range of capabilities of a human being. That just means in one very narrow area, it's able to perform as well or better than a human being. But that doesn't mean that it in general is as intelligent and has the overall learning and thinking capabilities of a human being. So if it had all the overall learning and thinking capabilities of a human being, that would be strong AI. But if it's able to just do one very narrowly defined task, or even a few very narrowly defined tasks, but not kind of synthesize all of them into a general ability to reason, then that's just weak AI. And so what we have today is we have weak AI. We have computers able to do many narrow tasks at or exceeding the ability of human beings. But we don't have anything even close to strong AI, which is a machine that would actually have all of the reasoning abilities, learning abilities of a human being, and able to go quickly from one domain to another domain and totally understand what's going on and be able to quickly pick it up. Even though we have made great advances in weak AI. So particularly, you've probably heard about something called neural networks, and artificial neural networks have been able to, in the last few years, make leaps and bounds. It's an old technology. It's been around for 40 years. But in the last few years, we've seen really big advances in neural networks for things like voice recognition, image classification, text-to-speech. Really, really incredible advances. But that doesn't mean that you can take a machine that's been trained to do text-to-speech and then say to it, okay, now I want you to do live commentary on this soccer game, and it can do a good job at it. Because it can't take its abilities in one domain and translate them over to another domain, it doesn't have general intelligence.
And that general intelligence is what kind of a big part of what makes us human, right? That ability to build connection. And part of my understanding is that one of the reasons that we can't have computers do it yet, or have been able to mimic it, is that there's a lot of mystery there in how human brains work and how we're able to do it.
Right. We don't really understand completely how the human brain works. There's an incredible amount of research every year in the field of neuroscience, trying to understand the human brain and understand animal brains as well. And we get more and more ideas each year about how they work, but we don't really at a fundamental level understand how thoughts are made and how human learning works. We understand sometimes in narrow areas how it works, how one part of the brain, we have better ideas about some parts than we do about other parts. But we haven't mapped the whole thing to the point where we really understand how human beings make thoughts and come up with new ideas. So if we don't understand how humans do it completely, it's very hard to model that in a computer. So what we do in artificial neural networks is we use human neural networks as a jumping off point. But we don't pretend that the artificial neural networks in computers are real models of human neural networks. They're not. They're not even really approximations. They're just leaping off from the idea of human neural networks as a starting point for where maybe some of their ideas came from. So we're not really, when we build today an image classifier, we're not going and thinking, well, how does a human classify images, and then trying to encode that. That there is algorithmic work like that. So for example, my dad was very involved in chess and particularly in building computer chess programs. And there was a big debate in the 1970s. There was two different kinds of chess programs. There was one kind of program that tried to model human thinking about a position. So it was very positional. And it would try to think, what does a human being weigh in different parts of a chess position? And then there was another kind of program which just used brute force. It just tried to do what a computer's good at, which is calculate, and calculate as deep as it could. Now, the calculation type of program is what won out. So it turned out that just being able to calculate a lot deeper than a human being was more valuable than trying to instill in the computer's thinking all of the ways that a human thinks about a position. So that's what we've been successful with, is exploiting the computer's incredible calculating ability more so than trying to model human thinking perfectly in a computer program.
Another buzzword that we hear maybe around artificial intelligence or in computing is machine learning. Can you give us a definition of that? Yeah,
so machine learning and artificial intelligence is kind of like a square is a rectangle, but not all rectangles are squares. So machine learning is a sub-discipline of artificial intelligence. And it has to do with how can computers improve on their ability to, let's say, model some function. So everything like, I want to play chess. Well, there's some complex function that says, what's the best next move? So machine learning says, instead of just telling it, here's how you play the next move, over time, by looking at a lot of data, basically by looking at a lot of previous games or playing a lot of games of chess, it tries to, over time, better figure out what the answer to that function is, how that function should be written, if you will, if we were writing it as a math equation. So machine learning is about using data to better approximate the answer to a function. So in machine learning, we usually have to have a big data set that we start from. And then we use that data set, which might sometimes be labeled. We call that supervised learning, where we have some that we say this is the good way to go, and this is some data that's bad way to go, and we want to go more towards the good way to go data. And we also have unsupervised learning, where we just kind of give the computer the data and we say, here, go at it, and we see what comes out. So there are some machine learning algorithms that are supervised and need human intervention as they go to guide them in the right direction. And there are some machine learning algorithms that are unsupervised, which just say, Okay, computer, go at it and let's see what you come out with. They're usually used for different kinds of things. For example, k-means clustering is an unsupervised learning algorithm, and it says, okay, if I have a bunch of data, can I figure out what some groups of that data are without the human saying ahead of time, here's where I think the groups are? Whereas a lot of artificial neural network work is supervised learning, where we say, okay, here's what I kind of want to get out of this. Like, I know that these are the right labels for all of these digits that I want you to read. Like, maybe it's scanning mail for the post office. And it says, hey, this is what I think this letter looks like. This is what I think these numbers look like. And can you try to now look at all these examples of letters and numbers? And then when you see other ones, try to do a good job at classifying them correctly. So depending on what our goal is, or what, if we even have labeled data available to us or not, we might have to choose whether we can use a supervised machine learning algorithm or unsupervised machine learning algorithm. I went on a bit of a tangent there, but basically machine learning is about how can a computer use data to better approximate a function over time. So machine learning does not work the same way that human learning does. So that's one of the amazing things about human beings. You can show me something just a couple of times, and because I have general reasoning, I can start to understand it, right? But a computer, to approximate a function with our current artificial neural network techniques, usually needs thousands, tens of thousands, millions of examples to start being really good at doing some tasks that human beings can learn in just a few examples. So that's a really interesting difference between the two. Of course, I'm talking in very general terms. There are some things that computers through machine learning can become better at than any human being.
So you've touched on this now. You touched on clustering, artificial neural networks as parts of machine learning. Another one to touch on would be linear regression. What is that?
So the reason I want to talk about linear regression is just that it's a technique that a lot of people are familiar with, and they might not even be aware that it's actually considered a type of artificial intelligence. So if you've ever taken a class on economics, or you've taken a statistics class, or you've taken a class in some of the other social sciences, you've probably seen linear regression. You don't need to be a scientist to have seen linear regression. It's just trying to fit a line across a piece of data so that we can approximate when we see a new piece of data where it would go on that line. It's a pretty simple linear regression is a pretty straightforward technique. But believe it or not, that's considered an artificial intelligence technique. In fact, it's considered a machine learning technique. And the reason I wanted to bring it up is that I feel hopefully it demystifies for people that when we're building artificial intelligence, especially weak artificial intelligence, what it's actually doing doesn't have to be a total mystery. It can be making these predictions using techniques that are actually we're pretty capable of understanding. So there's a lot of different, and I also wanted to bring it up because there's a lot of different techniques that fall under this big umbrella of machine learning and this even bigger umbrella of artificial intelligence. So artificial intelligence is not just one thing. It's not that we've created one artificially intelligent program and we keep reusing it. There's many, many different algorithms that we've invented that we use under the umbrella of artificial intelligence and say, hey, this algorithm is helping this program model human-like intelligence.
Can you talk a little bit about what expert systems are?
Expert systems were one of the first areas where artificial intelligence made a big splash. And they are basically just a huge series of logical questions and answers that lead a computer program to some kind of conclusion. So they're totally based on logic instead of being based on machine learning or being based on some of these more modern algorithms. They're really just saying, what's the answer to this question? Is it yes or no? And then it goes a different direction and asks you another question that's a yes or no. And as you go through all those questions, it's able to make some kind of determination. You can think about it as a giant, what are those graphs called?
Flowchart.
Flowchart. You can think about an expert system as like a giant flowchart that might go a little bit beyond that, use some insights from all the different questions in the flowchart. But so this was one of the first areas where artificial intelligence was successful in actually producing useful software. One area where expert systems have been used is in medicine. So sometimes you need to figure out a diagnosis, but it's not totally obvious. There are expert systems in medicine where you input all the information about the patient and their symptoms, and they come out with some kind of diagnosis. And these expert systems are built on previous human intelligence. So humans are saying, this is how the answer to this question should guide us one way or another. And then the accumulation of all those different questions together leads you to some kind of conclusion. That's a really easy thing to understand. So you can probably figure out why that was an early area of artificial intelligence, but one that actually did make its way into commercial software. What I think is interesting about that is, again, it illustrates how big this term artificial intelligence is. That's a totally different way of approaching a problem than an artificial neural network.
One area where artificial intelligence has been pretty powerful and but has beat humans has been in chess.
Yeah, we talked about it a little bit earlier. And what's interesting again is that that's the way that chess programs became so good was not through machine learning. It was through just what we call adversarial search, which is just being able to search in the game of chess many positions into the future. So we think like a grandmaster, the top chess player. Most of them, on average, can look about 8 positions into the future. So they can, they're of course pruning out many different possibilities, because in a chess game, a single position can have 26 different possible moves. So you do 26 to the 8th, that would be impossible for any human being to look through. But really, really, really strong chess players, we think, can look about 8 positions, 8 moves, if you will, into the future. Although we have to be careful. In chess, a move is actually both white's move and then black's response. So we actually call 2 together a move. In AI, to make it more clear, we call it a ply. And in chess, you'd call that a half move. So just black playing or white playing is like a ply. But anyway, so we think about a grandmaster as being able to look 8 ply into the future. And he's doing that, or she's doing that, without actually looking at every position. They're right away pruning out just the ones and the moves that they think are actually going to be good. Now, a computer, a modern chess-playing computer using adversarial search, can look 25 ply or 30 ply into the future, and they actually can be looking at almost every position. Now, of course, even those numbers would be way too high, even for a computer, so they are also pruning out using usually an algorithm we call minimax with alpha-beta pruning. They're usually pruning out avenues that really don't make any sense. But they are looking at many, 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 many times more positions than even a grandmaster is. And this is how computers got really good at chess, is just by calculating more, doing deeper calculation, looking further ahead than a human can look. And so the best chess playing program in the world today is rated on a rating scale of about, 3,300, whereas the best grandmaster is like 2,800. So they've significantly exceeded the abilities of the best grandmaster. No, even the world champion, Magnus Carlsen, I think is the chess world champion right now. He can't beat the best chess playing program, and at least not consistently, for sure. So the interesting development, though, the last few years has been that now they're starting to use techniques from machine learning to try to train even better chess programs. So it seemed for a long time that chess was just becoming an uninteresting area of AI, because just using this really deep calculation was the way that we were just getting better and better programs. But what's made it interesting again now is it seems like using some machine learning techniques, the programs might be able to get even better. So chess is such a big game. It can't be just solved by artificial intelligence. What would solving it mean? Well, weakly solving it would mean just being able to tell you what the best first move is. We can't prove for sure what the best first move is in chess. There's theory about it. There's been some attempts, but we can't tell you what the best first move is in chess. Some games that have a small enough search space, like Connect 4, have actually been solved. And that means we know for any position in Connect 4 what is the best next move. And so that also means that we know the best first move in Connect 4. By the way, it's center. So if you're playing Connect 4 now, you know. But chess is too big a domain. That's also why it's kind of interesting too, is it's too big a domain to actually solve. There's too many different possible positions. So just being able to create a program that can play better than human beings was seen as a really big accomplishment because it's such a complex game. And that's why there was so much publicity around the Deep Blue IBM program in the 1990s that beat the world champion at the time, Garry Kasparov, because it was considered such a human achievement to be such a human-like achievement to be the best in the world at chess, because it requires so much deep thinking. But if it turns out that it's all just, if there's a domain that's just about calculation, we can make a computer do it better than a human being basically every time. But if there's a domain that requires intuition, that requires taking ideas from multiple different areas and synthesizing them together, then a human being is usually going to have the advantage. Another interesting thing in chess, though, is there's also competitions where a grandmaster plays along with a computer against another grandmaster playing with a computer. And there's some evidence that actually the combination of human intuition with a computer can actually be stronger than a computer alone.
That's pretty cool. The other thing that I've recently heard about, or relatively recently, is that now computers have also been able to beat the best Go players.
Yeah, and Go, one of the reasons that was interesting, first of all, there's been a lot less research into it. So chess was kind of the first game that got a huge amount of interest in the artificial intelligence community. In fact, even going back to Alan Turing, often considered the founder of the field of computer science and also, in many ways, the founder of the field of artificial intelligence. Already back in the late 40s, early 50s, before he tragically died, he was working on ideas for a chess playing program. So chess was one of the first areas of artificial intelligence and one of the most deeply researched and studied areas. Go, on the other hand, didn't get as much attention. One of the reasons why is that it's even more complex in terms of the search space. There's even more possible different positions in Go than there are in chess, which is really saying something because there's an incredibly high number of possible positions in chess. So what's happened recently is a program from DeepMind has actually been able to beat the world champion in Go. And a lot of people thought that that was going to take a lot longer than it did. And the way that they did it was using machine learning techniques. So they actually built a hybrid that was using both adversarial search and machine learning techniques. And this is interesting because using just the way that chess got so good, just doing deep calculation with adversarial search, searching as deep as you can, was not good enough to build a world champion Go program. But when they combined machine learning into the mix, they were able to create now a world champion Go program.
So I think one of people's, or the biggest maybe concern around artificial intelligence has got to be, are we going to get taken over by computers? Are we looking at this becoming a Pandora's box and Terminator playing out in our lives? Do you think that's going to happen?
Well, there's some really smart people that are sincerely concerned about this. Two people that have spoken out about this are Bill Gates and Elon Musk. And they're much smarter than me, and they're really concerned about it. However, personally, while I do get a little freaked out when I see some of the Terminator movies, I personally am not that afraid of it because we really don't know how, and maybe they have some more insider information than I do because they talk to the best scientists in the world, so they probably do have a lot more information than I do. But I do know that we're not anywhere close to building an artificial general intelligence. We've made great leaps in weak AI, but strong AI is still probably very far away from us because we don't really know how to make strong AI. So there's a lot of research in this area. And if somebody did create a strong AI, yeah, that would be pretty scary if someone did create a strong AI. But since we don't have any evidence today that we are close to a strong AI, I'm not personally afraid of tomorrow or in the next 10 years even there being some real threat from an artificially intelligent machine. Because each of these programs is so narrow. Just because you know how to play chess really well, first of all, it doesn't mean you know why you're playing chess. Mm-hmm. Second of all, it doesn't mean you're actually have any feelings about, oh, I want to be the best in the world at chess. You're just doing what your programmer told you to do, and you learned how to be better at it using these machine learning techniques. But all that really is, again, is an approximating a function. It's being able to kind of figure out a math equation pretty well to to figure out what the best next move is. And that's true about all these big leaps and bounds we made the last few years. That's also what image classification is. It doesn't mean that the computing program actually understands the image. If it tells you the image has a river in it and it has a blue sky in it, that just means it did statistical analysis over a huge set of images that also had rivers in them and blue skies in them, and was able to come to the conclusion that this one was similar to those other images that had rivers in them and blue skies in them through the approximation it was able to make by learning over all that other data. The interesting thing is that with a human being, I could go to you one time and say to you, well, there's a blue sky and there's a river, and then I could show you another picture and you could tell me right away that there's a blue sky and there's a river. If a machine could do that based on one example, then I would be pretty scared, because that would mean it had real reasoning abilities and not just the ability to do vast statistical analysis with the way that we do artificial neural networks today. Now, there's tons of research. Do I think in the future it's conceivable? Well, sure. If you think about that the human being's brain is just a biological machine, well, we're able to model other biological machines mechanically. So perhaps in the distant future, we'll be able to model the human brain using computing. But think about this. The human brain has approximately 100 billion neurons. And each of those neurons can be connected to tens of thousands of other neurons. Just right there, the number of connections in the human brain is difficult for even our fastest computers to even get close to approximating, let alone the fact that we don't know how they really work together and what they're really doing to create thoughts. We've been able to model the neurons in some very simple animals, like some very simple worms, completely in programs, but they have about 300 neurons in some of those animal models that we've been able to create programs for. So the orders of magnitude that we're away from being able to just mechanically look at the neurons, let alone really understand them and see what they're doing, is so far away. So I'm not worried about Terminator happening. In fact, I think that too much public discourse that makes people fearful of AI is almost dangerous, because AI is able to actually solve a lot of problems for us right now, a lot of safety problems. You think about the self-driving cars on their own, right? 40,000 people a year die in the United States of car accidents. If we could reduce that because the cars are no longer making human error, right? We could save tens of thousands of lives every year, not let alone what we could save globally. So too much fear of AI can actually lead us to not go down paths that are going to, in the very near term, not using anything close to artificial general intelligence, just solving very narrow problems, create a lot of safety and health benefits and economic benefits as well.
So pretty much we're not going to get taken over by machines anytime soon. And really artificial intelligence allows us to solve some pretty interesting and important problems in our society. And we're just going to keep exploring and keep learning more.
Yeah, and just the other thing I want to reiterate is that it has to do with a lot of different techniques. We say artificial intelligence, but I've just mentioned a few on this podcast: adversarial search, expert systems, all the different kinds of machine learning. There are many different algorithms that fall under the umbrella of artificial intelligence. It doesn't mean just one thing. The thing we hear about the most the last few years is artificial neural networks, but they're probably the most exciting field in artificial intelligence right now, but they're just one aspect of this broad term. But all of these techniques are very narrow. They're able to be applied for solving one specific kind of problem. Sometimes we can broaden out how they were used to solve one problem to solve another problem, but that doesn't mean that the computer actually has any motivation, doesn't actually understand what it's doing. It's not thinking back at you the way that you're thinking about it. We often personify it, but it's not a person. It doesn't have any feelings. And it doesn't have any motivation to do anything bad except for what a human being might be programming into it. And it's not reasoning. It's not taking its ideas from one area of its I don't want to use the word life, one area of its programs and using them in another area of its programs. It's doing very narrow tasks, sometimes better than human beings, but not with the understanding of why it's actually doing them or how it can use what it's learned from one area in another area. It's basically just with the really exciting techniques the last few years, they really are mainly just statistical modeling in many ways. One other one I'll add in, Jeopardy. A lot of people remember the IBM Watson machine that beat people in Jeopardy. I brought that up because, again, even though it seemed like it was so smart, right? It was answering all these questions. What it was doing was doing statistical analysis over a huge corpus of human text. So looking at all of Wikipedia, looking through, other famous books, browsing the internet, taking all that data, analyzing it, and then being able to do statistical inference based on the questions that it was asked. There's a big difference between doing statistical inference and actually having understanding. And that's what human beings have. We have understanding of the things that we do every day. We don't just go and every time do a model of every single example we've seen of something and then come to a conclusion based on it. That's a good way, actually, of thinking. Statistics is really helpful, and that's a really logical way to go about life. But we actually have a lot of reasoning that goes on beyond just statistics in a human being. Well, there's a lot more we could talk about with artificial intelligence, a huge topic, but we've already gone over half an hour. So let's leave it for another episode. Tell everyone how they can get in touch with us on Twitter.
So our handle is at Kopec Explains, KOPECEXPLAINS.
And it's been really great having you this week. Don't forget to leave us a review if you can on Apple Podcasts or your podcast player of choice. It really helps with the show. And we'll see you next week.
Thanks for listening.